All right. Well, let's just go ahead and get going. Hopefully more people. Hopefully we get a few more people straggling in and they don't miss too much today because it's a pretty big topic. But did people feel a little better after we went over arrays again last class?
I'm a little out of practice. I didn't get to study it all.
Okay. Well, we'll have a lot of. After I cover this material, functions are like by far a much easier thing for me to create assignments around because they're self-contained. So it's very easy to test. Everything else requires a little more work on my part. So it's much easier to write tests for stuff going forward with you guys working with functions. In fact, yeah, it wasn't too bad. And then we'll continue to use arrays, but from now on we'll probably use them wrapped inside of functions. Pretty much every homework you guys work with from now on, functions will be the starting point, the central aspect of them. And then, different variables and other things will sort of build off of that. So that's what we're going to get started with today and really just spend our whole day talking about this concept of functions. I introduced them just a tiny bit in last class, which was function is a group of statements that perform a task. And we talked just a tiny bit as well about some of the benefits of functions. To let you write code once and reuse it multiple times, use the same logic with different values, break up code into small pieces, isolate variables and logic. Some of this won't make sense right away, but you'll begin to understand why these points are true. So I'll try and come back to these at the end of class today, and we'll look at the ones that we can emphasize, like how functions help us out with this. And it allows abstraction, so you can think about code at a higher level. So before I get into how functions work here, has anybody here, people familiar with algebra, right? I'm not sure if everyone's taken it, but so I'll bet you're familiar with the concept of a function in algebra, right? And you may not have written it this way exactly, but an algebraic function might be like a function of x equals x plus 5, let's say, right? And that's a pretty simple concept. Basically, you put a value in for x, and then you get the result of whatever x plus 5 is whenever you're working with it. So if you feel comfortable with algebraic functions, that's a great starting point, but not a perfect parallel for how functions work in programming languages, because they're a very, very similar concept. The way you run code in a function is by making a function call. So, for example, our algebraic function that we have up there, if we call that function with, then the result is 12. It's called a function call in programming when you call one. And after a function completes, so it runs whatever code it's going to run, the program returns execution to the calling code. So here is the most basic example of a function that I could just about put together. And we'll move it over to this scratch space so we can actually run it as well. But I think it's a little easier to see right up here. So on this code right here, we've got a pretty simple print hello function. And you can see that we've got some code inside of it that just says console.log hello world. We should all be comfortable with that line of code by this point in time. The way a function is declared in JavaScript, the standard approach to declaring a function is with this function keyword, and then the name of your function, followed by the parentheses, and then a bracket and a closing bracket says this is the end of the function. So that's the sort of syntax for declaring a function is you start with this function keyword, then whatever you want to name the function. You use parentheses, then your curly braces mark the beginning and end of a function. So we have some code at the top here. I've got a note. This code declares a function, but it doesn't actually run the code in this function. So code in a function doesn't run until it's called. It's a way to put code there, but it's not run sequentially the way that we're used to all of our other code in our programs have been running up until now. It's only run when you make a call to it, and you call it I've got a couple examples here, like call the print hello function, then I even called it a second time. So if we go ahead and run our scratch file here, which we put the function in, and we look at our output, what you see is that, let me pull this up so you can see it a little more clearly. As I said, you don't see hello world printed out as the first thing on the screen. And that's because that code inside of that function didn't run until it was called. Instead, we ran console.log start program. That's why it's our first line of code. Then we called print hello, and you call a function a lot like when you declare it, except you don't use that function keyword. So you call it with the function name in parentheses. And we can even call it multiple times. And every time you call the function, basically what's going to happen is the code is going to pause the flow of code that you're in right there, jump over to the function, run whatever code is in the function, and when that's done running, it's going to come back to the point in time that you're at to continue running your code. So that's why we do this print hello a couple times, and then we have a console.log end program. Are there any questions about that so far? This is just the flow of how functions work. So I was trying to think of good examples of how I can represent this idea of how the main execution sort of pauses there, jumps over to the function does something, and then it comes back after that's run. So one thought I had might be stupid, might be fun, I don't know, we'll see, was the idea of, you know, something like a Mad Libs or something like that, right? So what I want to do here is let's go around. We'll start with Mike right up in front and have each person choose one of, like, or we'll just move down. So Mike, if you can think of an adjective, just any adjective, right? I should probably cover this up. And then Alex, a nationality. And oh, I'm blanking on the name. No, what's your name? Johnny, man. Like looking, person. And then a noun. What do we have next? An adjective. Getting lost. A noun. An adjective. We're not going to make it all the way through, so we'll just get through this plural noun. So then an adjective and a plural noun at the very back. All right? So this is, in my mind, I don't know, it's something that brings it back into more concrete or outside of code. And if this were function calls, like maybe this is a function call of get adjective or something like that, or get nationality, the way this might work is, let's say I'm the executing program, so I'm running through whatever I'm doing. So I'd be like, pizza was invented by a get adjective. Quirky. A quirky, and then it comes back to me and I go, get nationality. Italian. A quirky Italian chef named, get person, named Oliver. All right. So pizza was invented by a quirky Italian chef named Oliver? Twist. Oliver Twist. All right. To make a pizza, you need to take a lump of dough and make a thin, round. What? Adjective. Any adjective. Giant. A thin, round giant. Back to me. Then. All right. Make a thin, round giant table. Then you cover it with, and I get an adjective, a smooth sauce, mushrooms, mushroom cheese, and fresh chopped 4 times. Fresh chopped 4 times, right? But that's a little bit like, I mean, it's a little silly, a little goofy, but that's sort of what a program's doing when you're calling functions. So you've got something running through the code, and then it reaches a function call, and it the code jumps over, and that function call handles whatever it's doing, and then control returns to whatever called that function. So this is, like I say, the most basic of functions here. It's just returning something, or just logging something. But there's some other aspects of functions that are also important, and that's pretty much what we're going to be going through all day today. Maybe we'll get done a little early. If so, I can work through a whole bunch of extra examples of functions and how they work, and even show you some other syntaxes of functions, because this function print hello. There's actually 3 ways to declare functions in JavaScript. This is I'd say the most basic, or the one that has been around the longest. The other ones are slightly different syntax, but also work. So the next major aspect of functions is all functions return a value. Now this print hello that we just ran, it's a little tricky, but now we'll look at that in just a second. But a function can only return one value each time it is called, but each call to the function could return a different value. So every time you call a function, you can get a different value back, just like our algebraic function here. Every time we call it, we could get a different result, but it only returns one value every time we call it. So if we go back and take another look at our print hello function, and all we're really going to do now is let's just add a line that saves whatever value is returned. And the way you get a return value from a function, the way you save it, is you just assign it into a variable, just like we've been doing with any other value. And then we'll go ahead and print that out. So this isn't a big change to our code. But let's see what it does when we run it now. All right, so when we run the program now, what we get is we see our start program run, and we print hello. So we go into the function, which inside of it prints hello world. And we get back, that function returns a value of some kind. We assign that value into this returned variable, and then we log that to the screen. And what value did the function return? Undefined. And the reason it returned undefined is because console.log is also a function call, and console.log returns undefined. And this function doesn't have anything explicitly telling us what to return. So if a function doesn't have something saying, here's what I'm returning, it always returns undefined. Now, if we want to change this just a little bit, we can go ahead and change this code to return a value instead of printing something. So it'd be nice if we could control the value return from our function, and we can, and that's just using the return statement. So the return keyword is how we return a value. So let's change our function now. We're no longer going to call our function print hello. We're going to change it to call get hello. And does anyone know why it would be a good idea to change the name of this function from print hello to get hello? Because we're getting something, whereas the function isn't printing something out anymore, right? So what we're trying to do is be descriptive as to what our function is doing whenever with our function name. We're trying to have it be descriptive of the function. In this case, that function is no longer printing something. It's giving us a value back. If we run this, we get the same result as before, but it behaved a little differently. The difference now is instead of the function itself stating or doing a log and whatever it's going to do, it returned the string hello world. And then we just stored that string in a variable, and we're able to use that variable as many times as we want. In this case, we used it one time here, but we also just inlined this console.log and then wrapped get hello inside of it, because the way this line of code here will run is it will first run get hello, return whatever value that is, which happens to be the string get hello, and then it'll run the console log for the string that it got back. Here? So what you should have is you should have an open and closing parenthesis for get hello, because you're making a function call. And then the console log is also a function call with an open and closing parenthesis around it. Yep. Are there any questions on that? I mean, if there are, let me know now, because like I say, this is a very central concept. Pretty much everything we work with going forward will be functions. We're not going to be writing much code that exists outside of functions. All right. So next bit here, let's continue moving. So now we know we can return a specific value. We know we can log it. Another important aspect of functions, just introducing these concepts, is functions return immediately after running a return statement. So when a function is run a return statement, it doesn't run any other code in that function. It returns back at that point in time. So tweak our program just a little bit here, but not too much. Keep building on this same one so we can see what these changes do to our code. And you can even see my editor here yelling at me about this already. It's telling me that something's not good. But if I were to run this code, what do we think the result's going to be? Good guess. This will never be printed. Never. Yeah, I sort of told you with the note. But the reason is because, like I just mentioned, is a function stops at returns immediately when there's a return statement and doesn't execute any more code in that function.
So that's just an unnecessary line.
So once that return statement is reached, it's never going to run the console.log. In fact, that's why my editor here is yelling at me. It's got this little squiggly line under it. And it says, unreachable code detected. There's a return statement above this. I know that you can't possibly get to this code and run.
Would there be any reason to have that ever? I mean, is that always going to be the case? That's unreachable?
It will always be the case, however, and there are times where you may do, a function can have more than one return statement. For example, you know, you can, let me do something a little silly here. Math.random times like 10 plus 1. Let me make math.round. All right, so we're going to get a random number between 1 and 10. And then we can say if random is less than 5, return hello world. Let me indent this stuff a little better. Else, you know, we can return a different message. What's a good message to return in that case? Goodbye. Right? And then we could still, like, I'll do this just to show it. So you can even tell this can't be reached, and that's because I have an if and an else, which means one of these two cases will run. One of those two returns is going to happen. But it'll be a little random. It's different each time, depending on what the random number is that we get out, right? So it's either going to go into the if branch, return hello world and end execution there, or the else branch, return goodbye and end execution at that point. So you can have multiple return statements, and that's why you can end up in the case where there may be code that you don't realize is unreachable. Like, oh, I didn't realize that there was no way for me to get there, you know? I didn't quite understand that that could happen. So yeah, the really blatant example I just showed you, you'd never write code like that because you should realize, oh, this is never going to get reached. But
When you start getting bigger and bigger, there's a possibility.
yeah, there's a lot of possibilities of you missing how the code interacts with itself. All right, any questions so far? Keep chugging along then. So now we know that functions are declared using this function keyword and then the function name, parentheses, and use brackets to designate the scope of the function. We know that functions are called using that same parenthesis type notation, but you don't use function keyword. We know that functions always return a value. Even if you don't explicitly return one, it returns undefined. And if you use return and return a value, you never run any code after a function returns. Some of the other aspects of functions, next one we'll talk about is you can also declare variables inside of functions. So the ones that we had so far, we didn't really declare a variable, but you can do that. And a variable declared inside a function is a local variable. So it's local only to that function. They're limited to the scope of the function. And we haven't talked much about scope yet because we haven't had anything in JavaScript or anything in traditional JavaScript at least that worked inside of a different scope than something else. Now we do. So functions have their own scope. We'll talk a lot more about this going forward because there's a lot of other aspects of code that will have scope as well. But basically what that means is that anything declared inside of a function, like a variable, can't be accessed outside of it because it doesn't exist outside of that function. So let's take this get hello. Again, building on our same example. And this one's just a little bit different than our other ones in that we declare this var hello variable locally inside of it, right? And then we go ahead and log the result of calling get hello right here. And then we try and log hello here as well to see what the result is. And we're going to see what happens there, which is we've got start program, hello world, and then our code threw an error saying that hello is not defined. And hello is not defined because it only existed inside of this function. It doesn't exist outside of that function's scope.
So what if we were to, I guess, extend it to that program?
What if you were to what?
Like extend the brackets to the end where it says console log any program. But the answer is within that, or
If we did something, I mean, it would, yes. Now we wouldn't
you wouldn't
here. Well, we can do that real fast, but there's at least one problem with doing that. What?
Oh, it would just return hello.
Oh, because you don't have, it's saying to do all of this stuff, but it doesn't have any steps after, right?
It doesn't, remember, a function only runs when it gets called. So where is our function call? No, we have no function call anywhere in this, right? It's a little easier if I indent it all. So you can sort of see, if this is all inside my function, where's my function called? I can't call, like, I was about to lie. I was going to say I can't call a function inside of itself. You can, but you can't initially because the function isn't called. So how am I calling it? All right, so now let's say I call get hello here, right? Still nothing.
Console.log.
I do have these console logs in here.
So that's inside the function.
It is, but I called the function here. So, I mean, you already hit on it earlier.
Isn't that unreachable code?
It's unreachable, yeah, because I have a return statement here, right? All right, so let's keep tweaking this. Let's move this down here so that the other code has a chance to run. What?
That was weird.
There's a lot of going on here. By just by moving that bracket down, I did a lot of magic stuff. So let's try and walk through the code. Let's see if we can figure out what just happened. A lot going on, but let's see if we can figure it out. All right, we call get hello. Ding ding, and this is what you should do when you run into these types of problems. It assigns a variable, hello, to the string hello world. All right, and then it calls console.log start program. Got it. Let's just check and see if we can. Does it look like that was happening? Yeah, it looks like that happened a lot. Okay, so what's our next statement? Console.log calling get hello. So this isn't something I would normally introduce immediately, and we'll come back to this, but that called the same function. It can see this get hello function, and it calls it, so it jumps right back to the top, because this is the code now that holds on to whatever's going on. And it's going to run down, it's going to assign a variable inside of this call to get hello, called hello world. It's going to log start program, and then it's going to call get hello.
And just keep doing it over and over.
And it just keeps doing that and doing that and doing that, which is why it then says maximum call stack size exceeded. You called too many times before returning from anything. That's too many items. I can't do anything with that, right? We'll get into that more because it's not usually something that's introduced immediately. It's like recursion, a function calling back on itself. But another aspect of that, and I'll just keep talking about this stuff. It won't all make sense at first, but it will over time, is that each one of those calls to that function has its own scope. So the scope for each and every one of those is unique. Yes?
For all the console.log, do they all have to be under a function if it's not calling the function yet?
They don't have to be. You could put them up above it. You mean like, let's do this. I put them under it intentionally to sort of convey that even if the code was after the function, the function didn't run. So you mean something like this, a console log up above. Oh yeah, I've got my error here. So let's get rid of that. So we can see this run. That works just fine. You can put function definitions sort of anywhere in your code, but it's a good practice to declare a function before you use it. So it's a good practice to do it like if I had this console.log up above my function, that even works. And that gets into complexities of how JavaScript works and stuff that you probably don't need to know about right away. But when JavaScript sort of looks at this file, before it runs any of the individual lines, like what would happen if you were in the interactive prompt for a node or whatever, where it's running each line one at a time. When JavaScript gets a whole file, it actually looks through this whole file real quick and takes certain actions. And one of the things it does, it says, oh, I've got some functions here. Well, just essentially, it, behind the scenes, moves this function thing to the top of the file. It's like, yeah, move that to the top so that anything can use it in case somebody tried to call it before it was declared. So it does some smart stuff to try and make that work for you. But it's not a best practice especially because a lot of other languages don't do that. A lot of them will cause or have an error if something like that happens. And I think, let me check this. I'm not 100% sure on this. All right, I think I've got the syntax wrong because I never used this. Try it. Is this right? I have to make sure I get the syntax correct. Okay, that should be right. think it makes a difference. But maybe use strict as a mode that doesn't cause an issue with this. There's certain modes in JavaScript that can cause problems if you do something like that still. Use strict is something that JavaScript has to sort of tell it like, be more strict around some rules in this language, because I showed you some really weird quirks before, like how not a number equals a number or whatever. And so use strict as an attempt. I don't think it does anything with that one, but there's a lot of other little edge cases that it tries to polish up to make you less likely to do something by accident that's a problem. But yeah, it's best practice to always declare your functions before you use them. All right, any more questions on that? No? Sweet. So that was talking about this concept of a local variable and scope, the first time we've introduced that. So now, I mean, this is sort of cool and all. We've got some functions. We can print some stuff out. We can return something from them. But so far, they're not that useful. So what do you mean? Like, we go back up to this list. Functions allow us to, what benefits have we gotten? We can write code once and reuse it multiple times. Okay, we've seen that, right? It's where we can call the function and use that same code again and again. That's cool. Use the same logic with different values. Well, that doesn't seem to be working so far. So in that sense, we're not quite like this algebraic function that we had used before. Break up code into small pieces. Yeah, we get some of that. Isolate variables in logic. Well, we just talked about local variables, so we can isolate stuff that way. And then we'll talk a lot more about the abstraction parts in a minute. But the next major aspect of functions is functions can take parameters also. Just like this algebraic function takes x as a parameter. Yes?
I don't know if I'm right. That's mean function make easier to code when you try to do something. Or if you have a lot of work, if you try to use function to code it, it's like better and you can go fast.
Yeah, we can talk a lot about the different benefits of functional programming and why functions are such a big benefit. So we'll get through a little bit of this, and then I can talk about a lot of different aspects of why they give you big benefits, right? But so okay, I say I'll take a minute and say one of the biggest reasons that I like functions or whatever is going back to, again, what one of my first professors taught me in college, which was a good programmer. I want to make sure I'm broadcasting just because I've forgotten a couple times. A good programmer is a lazy programmer. So don't do something again if you don't have to. And that's what a function lets you do, is do something once and then not have to do that again in the rest of your code. And there's a lot of other benefits to it, but to me, that's like the biggest thing. I don't want to write the same code 5 times. I want to write it once. Ugh. Writing it again is annoying, right? I don't want to cut and paste, and a function gets you away from having to do any of that. And parameters are one of the big reasons we're able to do that. So functions take parameters, which are like local variables, but just slightly different. Parameters are declared in the parentheses after the function name. So a lot like this, again, algebraic function like f of x. You supply the value for parameters when calling a function, and the supplied parameters are called arguments. So it's a little confusing. We use 2 different terms. They're parameters on the function, but when you call it with arguments. And those arguments become the values for those parameters. And then different arguments can be provided each time you call a function. So let's go back up, and we're going to reuse, again, our hello world type program, but we're going to tweak it just a tiny bit here. So this time around, we've added a parameter to our function. We've changed it to be say hello, going back to something close to that original variant, that print hello. And we've added a name parameter. So we just declared it just right here within the parentheses as name. And then we can use that just like we would any other variable inside of our function now. So now we can print hello plus name, just like that. And even better, we can call this function with different names, and it's going to give us different output each time using the name. So now we were able to call it, and we get hello Jared, and hello Manuel, right? So now we're starting to get into some real powerful capabilities with our functions. So we can pass in, a function can take, what does a function take? Parameters. A function has parameters, and when you call it with arguments. Yeah, the arguments map to those parameters. So in this case, the argument, Jared, maps to the name parameter.
So if you want to call something besides say hello, name in those parentheses, Jared and Manuel, maybe you need to have a get function for the name that you want to put it. Like an equivalent, like a C out and like object.
So let's say you want somebody to put in a name, right?
I think it's prompt.
Prompt, yeah. It doesn't work inside a Node, which is one of the reasons I haven't introduced you guys to it. I'm going to switch over here for a minute, and we'll jump into the browser, because remember, this is also a JavaScript interpreter here, right? So let's play in here just for a second. I hope I may have to go to a simpler page, but so let's create this function. Say hello, and it takes a name. It's the same thing. It exists here. And if we did type of for this, by the way, type of say hello, it tells us it's a function. So a function is an actual type, just like a string is a type or anything else is a type. And now we can do say hello Jared, right? But we can also, and this exists in like your browser. I need to put together something. I just keep struggling over how to get something nice and clean for you guys to work with. Now that I've introduced functions, it won't be as big of a deal. But you can also prompt in a browser, and a prompt is like just some little dialogue that comes up. It's not going to let me do it because, all right. I'm going to dock this. I'm going to actually close this. I'm going to go to like, I'm going to go to this because I know that I'm not going to get any problems if I go to this first website. JavaScript. All right.
That wasn't better at all.
What?
That wasn't better at all.
Well, there's no JavaScript when the web was first invented. JavaScript didn't exist. It got added on later. So the great thing is I just know that I'm not going to have any problems here. So you can, in the browser, you can do a prompt like I did before, and it'll actually prompt you to put something in, right? And so we could combine those because this prompt is a function call, and we passed in a parameter, this what's your name string that you guys saw displayed in it, and it returns a value, in this case, whatever somebody types in to the prompt. So I could do say hello, prompt, what's your name? And we could do Mike this time or whatever, and it returns that. So yeah, this is where you start getting into some really powerful capabilities. You can compose stuff and do very flexible pieces of code. And you could also, I mean, there's other stuff in a browser which we can talk more about, but you can pop up dialogues instead. Like we did the prompt, but there's also like a confirm dialogue. And these aren't used very often. But if we wanted to, we could instead like use the confirm dialog. Let's make this even more composable. Shouldn't call it say hello. So let's make this get hello, like we were doing before. And this one's just going to return this hello in the name. And we're going to compose some stuff. Let me see if I have this correct here. I think confirm is just this. All right. So you can go ahead and compose something. Let's get hello.
But they still use that function.
What?
JavaScript, like they say that you want to exit out or something like that. I think it's more so for like Adobe software and stuff versus seeing it in like the actual browser.
Yeah, you don't see people use that very often. And the reason you don't see people use prompt or confirm or any of those very often is because you can't control any styling on them. Those are controlled. No, you can't do anything to change the way they look. Those are completely managed by the browser. So the only thing you can do is change some of the words in them. You can't change their appearance and style them and stuff like that. So most people instead use things directly embedded inside of their website, which works a little differently. But yeah, we can compose something. So let's compose this, and let's have this be, I'm going to spell this name right, J-O-N-N-Y, or is there J? All right. And so if we walk through what that code did, right, so we just ran, we called the prompt function with this what's your name parameter. It showed that in the dialog. It let us type something in. When we pressed OK, it returned the value, which is now here in this code. So that value it returned was Johnny, the string. Now we called our getHello function that we just defined. Name is Johnny, and it returns the concatenation of hello and Johnny. So now here we have the string, hello Johnny, and we pass that string into our confirm function call, which pops up the confirmation dialog. So this is where you start getting into some really, really powerful bits of code. You can compose these functions endlessly and work with them. Now, you're not always going to nest them like that. A lot of times you'll assign something to a variable because it's easier to work with than it is to nest functions inside of each other. Like, at this point, it starts getting a little tricky. How many closing parentheses do I need? Where do I put them, etc.? But I hope people are getting a feel for the power of being able to compose stuff like this. Just by using a few small functions, we can do a whole bunch of dynamic stuff in the browser. Any questions about that? Oh yeah, it can get very confusing. That's why I keep walking through these. Even though we've run a lot of code now, I keep walking through what's going on and breaking it down. Look from the inside out, break it down, what's going on. Okay, now what do I have after I run this? What's here?
This is the first thing that it's calling from get hello from. That's the first thing it's going, and then it's going back and going to the other thing.
What it's doing is it's looking at this entire line, and it has to sort of parse the line from the inside out. Because it looks at confirm and it says, all right, I've got a function call here, but this function takes, you know, a string or something here. What do I have? Well, I have another function. So I'm not done. That's not a value I can pass in. I need to call this function call, right? Okay, so here's my function call for that. And inside of that, well, I have a function call. So first I have to make this function call, get the value from it and return it. Now I can call the one that was outside with the return value from that. Now I can go all the way to confirm and call that function. So walks all the way in, starts executing from the inside out, and then executes, and each one of those values is returned and used for the subsequent function call. That's a pretty complex bit of code there for, you know, just an introduction to functions. I'm not going to give you an assignment that is that complex immediately. We're just going to work with basic function calls, not sort of this very complex nesting that we're doing there. We will get to stuff like that, but we're not going to really introduce too much of that immediately. All right, any questions on this now?
So there, when you were saying say hello, name, and then it was, you don't have to define the names until you get down into the call functions of each one.
Until you call it. Yes, yeah. Basically, you could think of it as like a placeholder. It's a placeholder that says, all right, when I'm called, the first thing inside of my parentheses, the first variable there, or the first string, the first item there, I'm going to assign to the name variable on this function call. So actually, oh yeah, I'll show you another example, and then maybe I'll do this because it sort of helps out with some of that, I think. More hands-on stuff. I don't know. I like hands-on things to try and help me get outside of just staring at code because it helps me connect it with the real world. All right, so the next item, the scope of parameters is only within the function body. So the scope of parameters is the same as local variables. So now we're going to have a more complex function, just slightly. Again, increasing the complexity tiny bit by tiny bit. Now we have an add function. And instead of one parameter, it has two parameters, A and B. But again, the scope is just inside of that function body. So when I call this code, I'm going to get an error. And that's because, all right, I ran just fine. I passed it, I called add with the arguments 5 and 7, which inside of the function map to 5 is A and 7 is B. It runs, it returns 12. I go ahead and print that out, which we see printing out 12. But then I tried to print out A, and A isn't defined out here. It only exists inside of add every time it's called. So it doesn't exist outside of that scope. The same way that if I declared a local variable, it doesn't exist outside of that scope. Does that make sense? You good with that? Awesome. And then I don't really have a lot more, so we may get done early, and then we can work through some more examples or talk about some other stuff. But I have one more bit, which is that the parameter order matters for function calls too. So when you have more than one parameter, and you can have pretty much as many as you want, I should say the argument order matters is probably a better way to say that. The order of the arguments that you pass in matters. Yes.
Why use output A?
What's that?
For the subtract one or I guess
The add one or subtract one? Yeah.
why was it output A versus I guess A
Oh, it was returning the sum. I just had a bug in there.
Oh, okay.
The bug was that I tried to read A here, but A doesn't exist in this scope. It only exists in the scope of the function. Right? So maybe this will be a better example. So for our subtract here, if we call this, we get two entirely different values. And we get two different values because the order matters. Because the parameters are A, then B. So when you're calling it, you call it with a comma separating your different arguments. And the first time we call it, and A is 100 and B is 58, which gives us positive 42. But the second time we called it, A is 58 and B is 100. And so 58 minus 100 is negative 42. So whenever you're calling a function with parameters, the order of your arguments matter because they map to the same order of the parameter definitions.
So that could, for example, we had a case at work one time where they wrote a program
It could be something like this, very possibly. Yeah. Not certainly, but it could be something like that, where they just had the order of their parameters mixed up, or their arguments mixed up. All right, are there any questions on that? So, I mean, that's really the bulk of what I wanted to go through today. We've talked about the bulk of functions. I've got a few other topics I can go into around them, but I want to do another small hands-on. This isn't very complex or something. I only have a few here. So let me just, I'm going to pass, imagine these are function calls. So imagine that's your function, and this is yours. And I didn't put return. Imagine there's a return on these. Very simple functions, just to get some hands-on type stuff. So if those are functions, and I was the executing program, right, for hands-on work, I'm running through something, and I give them like add, subtract, multiply, and divide for anyone. Doesn't have them. What I would do when I call you is the same thing. I would say add. But I'm going to be a little lazy here because I don't want to have to write each one out. So instead, I'm just going to use some big parentheses and some numbers and act like I've written out the name of them. So if it was like the executing program, it would be a lot like this, right? Like I just give them this as the divide function. And oh, that's a hard problem for division. And you have to return back whatever the value is of that. So you know what that would be? I don't even know what that would be. Let me give you easier numbers for that. These would be easier across the board. So there we go. So if you were the function divide, you would give me back, what value would I get back with if you had those two parameters? Take it all out, actually. 4. All right, yeah, I just passed in 8 is A and 2 is B. So 8 divided by 2 is 4. And if I did it instead to subtract, so if you were the function, I call subtract for the same parameters. Be 6. And it works that same way, right? It's exactly like that for the program. Again, it's passing off control. Something else is doing some work, so I'm too lazy to figure out how to divide these numbers. I don't want to do that. I don't want to have to think about what it means to divide these numbers. It's too complex for me. So instead I say, you go do this work and just tell me what the result is. So the most canonical example of a function that we've encountered in every class that we've done so far is console.log, right? And it looked very simple. This, like what it does, it writes hello here. There is a ton of complexity going on behind the scenes. There's a ton of magic, a ton of complex, how computers work, how do I write stuff out, how do I accomplish this task taking place inside of, for example, this console.log function. And I don't have to know anything about it. I don't know how any of it works. I don't have any clue how this is writing out to this screen or what that means. And that's where we jump back up to our list of benefits of functions here. And we're starting to see almost all of these now. We can write code once and reuse it multiple times. All right, yeah, we've got that going for us. Use the same logic with different values, where we learned how to call a function with arguments, and they have parameters, so it's great. Break code up into small pieces. Seems pretty clear, but we'll have more examples of that. And now the last one was abstraction allows you to think about code at a higher level. So I only have to think about, I just want to log something. I want to do something like that, but I don't know what that means. I don't understand all the complexity behind that. Another really good example of a complex function It gets rid of a ton of complexity on my part that we've also used a little bit just because it's an easy thing to do, is this math.random. So there's a lot of complexity in trying to have a random number generator inside of code. Making a random number generator that is in any way reasonably random can be quite difficult. And I wouldn't want to have to write that code out every time that I did it. And in fact, I would get it wrong. Pretty much everyone who writes random number generators is going to do something wrong, and it's going to be predictable in some way. There's some way you're going to be able to figure out the pattern. And that's a huge problem if you rely on truly random numbers for something like encryption. Because if somebody can figure out any pattern in it, they're going to be able to break it. So I wouldn't want to have to write that every time. And I would, even worse, almost definitely get it wrong. And by just using this as a function call that I can call into that somebody else has done, I get all the benefit of all of the testing, all of the investigation, all of the bug fixing, all of the support, and everyone else in the world using this exact same math.random and finding problems with it. And I get to benefit from all of that without having had to write all of that myself or recreate it. So that's really getting into a lot of the benefits of functions. Sometimes you have ones like that that are built into your code and everyone benefits from them. A lot of times you write your own. But even when you do that, you get a benefit from the reuse of writing that function, and you don't have to code repeatedly. And it's a little subtle at first, but every time you write code, you're likely to write an error in your code. You're likely to have a bug of some kind. So it's much better if you write that code one time and only one time and deal with the bugs there and then reuse it so that you don't introduce that same bug the next time you write that same piece of code. So there are a few things that are, we haven't talked much about objects and stuff like that, but every language has certain things built into their language usually. And some of them have things that might be separate, like in a library, that are just sort of built into the language at a core level. And so this math object, if we did type of math, we'll see that it's actually an object. So the math object is one of the things built right into JavaScript it's part of the standard of it. So we don't have to go to a library to use that. But it is sort of the exact same concept. And probably the last, I don't know, week of class, we're just started week 4, right? So we got like 3 more weeks after this week. So probably the last week or so of class, we'll toy around with some node libraries and talk a little bit about that and how to use those same things in JavaScript. And that's, I was talking about abstraction and the benefits of functions here. Libraries do the same thing. Libraries are like another level up on that hierarchy. So they also let you reuse code that other people wrote, except they let you reuse a whole bunch of code instead of just one function. You can reuse a ton of stuff all at once with a library. So a function is like, I don't know how to compare it. If you were to think of a library like actual library with books, a function is like one book in the library, and a library has a whole bunch of different books that you can use at any point in time. So that's sort of like what it's related to. Yeah, the math one just happens to be one that's built right in. And I haven't talked a lot about this, but I would definitely encourage you guys to go look up some of this stuff and play with it. So one of the best resources out there to learn about this is known as the Mozilla Developer Network. You can go to the JavaScript portion. But Mozilla Developer Network is a fantastic website for people who do Firefox as a browser. And it has a lot of just amazing information about the language. It's really one of the best resources to learn how it works. but here is this built-in objects reference. And in fact, this is going to be a great time for you guys to really start looking into this. So I might, even though it's not something that'll be in REPL, like a homework assignment might be to go look into this and look at one of these objects, because we're going to introduce objects probably in the next class or the one after it, and find maybe a function on one of them. So here's the math object that we've just been working with. It's built in. And there's certain things that exist on this math object. So if we go down and look at the different, they call them methods. That tends to be the name of a function on an object. But if we look at some of these methods, we have more than just random that I've used. You've also seen me use, for example, round, right? Math.round. And that will return a rounded version of any number that you pass into it. And there's a whole bunch more functions that are on this that do really complex math as well. We have square root. We have exponent. We have hypotenuse and logs and random and tangent and power. So there's a lot of code that, you don't have to recreate when you get down to it, because somebody else has already written it. Like math.min is an example in here. And it just takes a series of arguments, I believe, and returns to you the smallest argument out of everything passed into it. And I can pass in any number of arguments to math.min, because there is some flexibility in some of that, which we can learn about in the future if you guys are really interested in it. But a function can take any number of arguments. There's just a different way to work with them when you do that. There's math.max, which is the same thing, except it'll return the largest number out of anything that you passed in. So yeah, I really recommend you start spending some time playing around on sites like this, MDN. This is a really great one. They even have things like JavaScript first steps. You're just learning about JavaScript. Useful string methods, and more. But great question on the library. Definitely maps pretty directly. So are there any other questions right now on the stuff we've covered so far?
Can you go back to the add subtract function?
Yeah. You just jotting it down so you have it? Yeah. All right. But yeah, functions are such a fundamental concept of programming, and they're going to make it much easier going forward for you to think of stuff in small individual units and write code that way without having to try and think about everything all at once. All right, if there's no other questions on that, I might quickly show you a couple other ways to declare functions. Now, these aren't essential. You don't have to learn these. There's sort of 3 ways to write functions in JavaScript. We've already looked at the function declaration. The other way that you can write functions when you're writing JavaScript is you can assign a function directly to a variable, like var subtract equals function. And when you do this, you don't have to give that function a name over here. You can just use this function keyword with the curly braces in place of it. And then when you reference it, you're referencing the subtract variable and calling it that way. So that's just another syntax. It doesn't really make much of a difference. To show you that, if we look at the type of subtract here, it's also a function. The same as any other type that we've done. But we wrote it out. Maybe it's a little easier for you to think of it that way, I don't know. Because, oh, I'm assigning it to a variable the same as anything else. And that's how I can reference it. There are some very slight quirks and differences between them, but it's probably nothing that you guys are going to need to worry about anytime soon. And then the other syntax is significantly different, and it's new. Both these two syntaxes that we've already looked at, those ones have been around in JavaScript pretty much since the beginning. This third syntax got introduced with what's known as ES6 or ES 2015. And why is it called ES? That gets into some complexity. We call this language JavaScript, but its technical name is ECMAScript. ECMA script. That's the technical committee name for JavaScript, but nobody ever calls it that. And then versions of it are called ECMAScript 2015 because that was the version of it that was released in 2015. That doesn't mean every browser uses that. It doesn't. It just means they updated what the language is supposed to do or what it supports in 2015. They said, here's everything that the language supports now. And then as the browser developers get around to adding support for it, they add that into their language. And with 2015, they added something that are called fat arrow functions. So a fat arrow function, I'm going to make this much simpler right now, but a fat arrow version of subtract at its most basic level looks like this. So you notice we got rid of a lot of the syntax around our other versions of our functions. We don't have the curly braces here. We don't have this function keyword anywhere. It's disappeared. We don't even have a return statement. This is the most basic version of it. And you can also write them like this. You can use a return statement and curly braces with a fat arrow function. But at its most basic, when you write it like this, what will happen is, remember what happened with console.log? Or what happened with our original print hello world or print hello program? What value did it return? The first one we had that just did a console.log like hello world, but it didn't have an explicit return statement. What was the actual value that returned? Do you remember? It was undefined, right? It didn't actually have a return value defined, and so without one defined, it just returned undefined. That's the biggest difference initially of these fat arrow functions. Is a fat arrow function, if you only have one statement inside of it, the return value will be the result of evaluating that statement. So that's why you can get rid of all of this extra syntax occasionally, writing them this way. And it does the same thing. It just is a much more minimal sort of syntax. I wouldn't worry too much about them. I'm introducing them. Maybe I shouldn't because it might cause confusion. We're going to focus on the function declaration syntax for pretty much everything that we do, at least at first. There's not a need for you to know any of the other syntaxes right now, but they exist. And if you run across JavaScript code that's using that, you can go, oh wait, I remember this was brought up before. This is a function, it's just written a little differently. So I need to think of it the same way. It's a function, it has parameters, it takes arguments when you call it, and it returns a value of some kind. If If you encounter those, they're just functions. They're just written in a different syntax, a different style. Questions on any of that? All right. Well, let's go over one more concept real fast, and then we'll be done early. We've flown through functions. We're going to have a lot of assignments to sort of get used to this stuff. And then these are, like I said, the foundation of pretty much everything that we do from now on. These arguments, by the way, that functions take, they can be any values. So an argument to a function can be a string. What are some of the other types that we've learned? We've got strings, booleans, numbers, undefined. What? What's the type of a function? What? We just learned that today. What? If we did type of add, it's a function. So a function can take a function as an argument. We'll definitely get into that, probably next class. You don't just have to pass in strings and numbers. You can pass in another function as an argument. And then objects are also a type, but we haven't talked much about objects. So that's another thing that you could pass into them. So functions can really take any of those. And then let's go back and talk just a little bit more about scope then, and then we'll be done. So let's look at some examples here to maybe try and reinforce some of this concept of scope. Scope in a programming language just means where a variable can be referenced, essentially. What happens when you're referencing a variable at that point in time. And I'll whiteboard this in just a moment because it might be a little confusing at first. So we'll just call the argument here arg, and let's console.log arg just to show that we're doing it. And let's add another one. I want to make sure that we understand our scope here. Console.log inside. I'm going to do something a little tricky here. I think this works. Might not. We'll see. Probably won't. Oops. Console.log. Global scope. Local scope. Exiting local scope. Let's shrink this down a little bit. Any guesses on what this program is going to print out? Yeah, that's pretty good. So yeah, what we're going to print is, we're in global scope, so we print that first. And then we call local scope, passing as our argument hello, the string hello. So when we're inside local scope function, our console.log for arg prints hello. Then we exit local scope and we console.log arg and we print goodbye. So is anyone confused by that? This has to do with the way scope works. So we'll talk a little bit about this. Something you're going to need to understand more. Keep emphasizing scope. But the way it actually works in the program, essentially, is you can think of it like this. All right, we've got this global scope here. And in here, we have created a variable called arg. And we pointed that at goodbye. Whatever, right? We say that has the value goodbye. And then we call our function local scope. And what local scope is going to do is it's going to create another scope here, another group in the sense of variables. And we create one in here, a variable called arg, and we say the value is hello. So inside of our local scope, when it looks for arg, it says, all right, arg is hello. And then once we get outside of that, it sees arg as goodbye. Sort of makes sense that it only exists within that scope, and that scope sort of gets deleted. And now, maybe I'll blow your mind just a tiny bit, we'll see. All right, we've added a little more complexity to it. Now, let's hear some guesses on what's going to get printed out. Heard some people get it right before. Okay. Our inside local scope function call, right? Or we print that. Undefined. All right. Okay. This is where scope starts to get a little confusing. I talked about this concept of global and local scope. What's actually happening in this example that we had before is you could call this shadowing. This is shadowing the global arg variable, which means that this is the only one that's going to be seen because it looks, what's going on inside of the program is it will walk up scopes until it finds the variable defined. So in this new case, we have say what as a variable defined here in the scope, some kind. And then when we go inside a local scope, it says, oh, he's trying to print out the say what variable. So it looks for it first in the local scope. And it doesn't find it. So once it doesn't find that variable in the local scope of that function, to the next level in the scope tree. And in this case, that happens to be global. The next level is always whatever called it. So it looks at this thing and says, all right, what scope is it now? Oh, there is a say what here, so I'll use the value of that. So scope isn't completely exclusive. They can look at the scope of items above them to see if a variable exists there and get the definition from it. But a scope that's higher up can't look inside of this local scope. And one of the main reasons it can't, once this function quits running, all of this essentially is gone. It, in a sense, deletes everything that was going on inside of there. All of that scope kind of quits running that call to the function. And you only have this scope, which is why functions return a value back so that you can get something out to work with in the scope that called it. So that's a pretty confusing concept. We're going to be working through scope a lot more over the next, it's going to be something very central to the rest of our classes as well. I don't expect you to totally understand that, but sort of a basic introduction to it. You guys seem to do a really great job today picking up functions. We'll definitely have a lot of assignments of just practicing those. And then we'll bit by bit introduce some more of this stuff around scopes and working with that. And next class, we'll probably introduce objects. All right. Go ahead and stop the